Ishan sir.
Thank you so very much, Singha sir. Thank you so very much for your kind words. I hope I am audible and my screen is visible to everyone.
Yes, sir. It is visible.
All right. So before I just begin with the session, I would just like to know what competency do we have in the world of artificial neural networks. So how much theoretically or practically we are exposed to the ANNs. So maybe I would request participants to put up some comments on the same over the chat, maybe out of 5. So artificial neural networks, right? So maybe on a scale of 1 to 5, where 1 means nothing and 5 means that, okay, you are pretty much champ. So how much you're exposed to the world of ANN? All right. So I'm considering that we have a mid-level knowledge with respect to the artificial neural networks, right? So we definitely have knowledge on what exactly is the perceptron, how it works, right? And then how we are going to use them in the world of ANN so that we can create some larger layers. Now, the next thing for my session to come up and begin goes like, are we exposed to the framework like TensorFlow or PyTorch to solve some deep learning environments? Anyone out of you guys have ever worked with the deep learning APIs from the TensorFlow or the PyTorch? Okay, Rajinder ji saying yes. That's wonderful. Right. So, what exactly is my agenda for the day? I'm just gonna write it over here. Just give me a moment. All right. So typically, my agenda is to come up and do something hands-on, and I am going to actually come up and code one CNN, the convolutional neural network. And typically, this is the one which is majorly responsible for having some image classification R&D kind of a work. And typically, we will be coding one. You can say a deep learning network to solve image classification, and we will be taking the use case from COVID-19 chest x-ray examination, right? So this is going to be the use case for our current session, and it's gonna be kind of the technical part where we'll be coding the things rather than much of the discussions on the theoretical aspects, right? But even though before I start doing this code and everything for all of you, so I just would like to come up and show you what exactly is CNN, how we are going to work on it, a small presentation where we can begin with, so that you have a just basic understanding on CNN for those who are actually kind of new to this. So guys, deep networks or deep learning is basically whenever you have to work with the neural networks, right? So machine learning is you create some mathematical models and you try to figure out what you want. But when it comes to the deep learning, you're trying to introduce perceptron as one central element, and you create layers of perceptrons, and you end up with something known as neural networks. So in the world of neural networks, we have definitely so many different areas to work with. So this convolutional neural network is one of the neural network which we can write, train, and definitely use to extract some meaningful information from the images. Or maybe even you would like to just basically go with a kind of a small use case like image classification maybe. So what this convolution net is all about. So enabling machines to view the world as humans will do. So that is the main goal here. Now, there may be a CCTV footage on which you would like to work on, right? Or maybe some images and the parts of images you would like to extract. Could be a case that you have an image of a room and you would like to know in that room image, how many electronic devices are there. Or maybe a video recognition where you would like to come up and see that, okay, in the play-based school, whether a teacher is abusing a child or not. Then there can be image analysis and classification, one of the very basic use cases. And typically today, what we will be doing is we'll be working on this image analysis and classification use case from the COVID-19 chest X-ray examination part. Then there is media recreation, recommendation systems, even the natural language processing, and so on and so forth. There is no limit when it comes to the applications of the convolutional neural network, or CNN in short. Now, neural networks or CNNs, right? So they actually work on image processing. And when we talk about an image is considered to be a matrix, and it's basically a matrix of pixels. And when I consider the pixel, it's basically the RGB value, right? So you can consider this one of the image, which is a 3x3 image, right? So it's just a matrix. So mathematically, we are just going to see it as rows and columns, where each and every row column concept is linked to the pixel. And pixel may have the RGB values for us. And when we have to work with the neural networks, so this matrix basically is flattened as features which we actually put across as an input to the neural network, right? So generally in the real world environment, what we do is we actually flatten this image and we use this image as a vector so that we can feed these features to the neural network. So we can see one of the transformations here, right? That how we can come up and feed the image as an input to any neural network. So image processing with the neural network. So guys, I'll put less theory, right? Even though just, small discussion before we do some hands-on practical part. So we're gonna feed the image to some multi-layer perceptron for the classification, right? So we may solve the problem for a very low resolution, right? But there could be a use case that you're going to work on high resolution images, right? So we do have megapixels these days, right? So if you take an image from your phone and you are using Google Photos as your backup application, it means that Google is already kind of considering that which image belongs to which human being. So those are high resolution images. They are not basic small images. So your neural network may not be able to fit in and do the better results for the classification part. And that is where you need to use convolutional neural network, which should come into action, right? So the CNN part for our discussion is where you need to always consider images or the videos to be processed on some high resolutions. So when you look out for an image, right? So your image is going to be having RGB pattern, right? And there are some other color spaces which also exist for images. They may be grayscale, they may be red, green, blue, hue, saturation, and the value. And sometimes they are this basic color in magenta, yellow, and so on and so forth. So typically your images are 3 color channels. If you see here, so it's a red, green, blue concept, right? And every channel will have, of course, a width, how many units are there, then there would be a height associated. They're all pixels basically for us. So image processing in the convolutional network, computationally, we are going to intensify the things because the dimensions for your images may go very huge. Could be a case, you're going to process an image which is 7680 by 4320. So the major role of the convolutional neural network is to reduce the images into some form which is quite easier to process, and that too without losing the features which are critically for getting a good prediction. Now, in case you know the concept of dimensionality reduction, right? So may I know how many of you are aware with the concept called dimensionality reduction in the data pre-processing? I just expect that we are clear on that part. The dimensionality reduction thing, guys, we are aware of. So very quickly, very quickly, I'll take you through this part here. So there is one small article here, right? So typically you will have data sets, and in the data sets, you'll have a lot of features, okay? So we don't want to come up and work on these larger features, and we would definitely try to reduce down the features, and we would like to work only on the meaningful features. And there are various different algorithms to work on the same. So our CNN approach is typically going to work in the same way, right? So when I talk about the convolutional neural network, so main aim is that we extract the meaningful features and we remove the other things. So how typically we are going to do that, right? So you consider that there is some image which is 5 by 5 by 1, and it's basically an RGB channel, right? So we have RGB channel coming up here. So in the convolutional neural networks, we work with something known as kernel functions. Now, kernel is a function which is supposed to come up and give us some convolved layer, which is going to be your meaningful data from the image. So this kernel function works in a way that for every set of your image, right, we are going to have this dot product coming up, and we'll get some convolved layer out of your images. So this is the main crux, or you can say the main concept behind the convolutional layer, right? That how are we going to come up and extract the meaningful data with the help of your kernel function or the kernel layer or the kernel channel. Then next thing is the pooling part. So pooling is the concept which is responsible for reducing the spatial size of the feature which you have convolved, right? And of course, moving ahead, right? So this is again extracting the dominant features, right? So that is where we use this pooling layer. And typically we have either the max pooling or the average pooling. So you have convolved your image and with the kernel function basically. So in the max pooling, you take out the max value, maybe 20 and then the 30 and then 112 and then finally 37, right? So in the average pooling, what you do is you basically take the average of all the elements in your matrix. So that's the pooling layer which we introduce so that we can further extract some more meaningful information. Now, of course, I am not diving deeper in the mathematical part of how CNN works, right? So I will be diving more deeper in the way that how we can actually implement CNN directly. So this part you guys can of course figure out and you can explore how it can work better, right? So we are limited on time, and that's the reason I've just put it across in a very basic way of introduction that how it can work. So there is a neural network, and we need to come up and fuse the neural network with the convolutional neural network, right? So guys, typically there would be some input volume or input image, right? And we are going to have some convolutional layer which we put in, and there would be a max pooling layer or an average pooling layer which we come up and put across, and thereafter you have your basic neural network coming along with it, right? So if I come up and try putting it once again, so there is going to be an image which is going to be fed to some hidden layers, and these layers are going to come up and do convolution for me and then the pooling for me. Till time we don't reduce the image to the image which has maximum features or the most meaningful features associated. And thereafter, you feed this information to your normal neural network. So that's why the term is convolutional neural network, because we just convolve the image, we extract the meaningful features, and we are trying to feed into the basic ANN thereafter, right? So my ANN can just take some input as flattened images, and thereafter some hidden layers, and with the softmax, we're just going to come up and give the predictions on, right? How many classes you have accordingly. So just a very basic theoretical introduction, right, to what is convolutional neural network. And if you just want to study deep dive on CNN part, right? So there is this, link to the tensorflow.org/tutorials/images/CNN, right? You can learn and read more about it here. And what am I going to do? I'm just going to code the CNN part for all of you here with the help of TensorFlow as the framework, right? And for this particular approach, I'm going to come up and take COVID-19 chest X-rays as few of the images. So before we start now, so anyone having any query or any question which you would like to bring on or discuss? So is the voice breaking for everyone? A quick audio video check with everyone. I think the network would not be a problem here. Okay. So we'll be now proceeding further. So what I got this COVID-19 chest X-ray data set. So if you can see in this folder here on the left-hand side, I have created this directory. So if you want to work with CNN and typically you want to work with the image classification part, I would just come across and put that you have to prepare your data set, and your data set works in a way that you have a folder here, and thereafter in the folder you create two different directories as test and train. All right. So test will contain testing images and train will contain some training images. Let's open this test directory and the train directory here. So in the test and in the train directory, I am going to have COVID and the normal as two directories. And if you'll see in the test and in the train, when I have created these two directories, right, COVID and normal, so these are the two classes. Okay. These are the two different classes for my CNN. So COVID may be 0, normal may be 1, or normal may be 0, COVID may be 1. The network would definitely take it accordingly. So this is my first part, right? Is going to come up and prepare the data set, which you can come up and think of the first part. So data set preparation is not at all a challenge. So in the COVID here, I have kept some chest X-ray images. You see, I'm not working with very larger data sets here because training the models on the larger data sets may be a big time challenge, as we have some normal images and COVID images, some few images. So my system can actually process these images well. So if you have larger images, of course, your model is a much better approach, right? So this is a COVID image. So of course, we may not be able to figure out medically that how this is one of the COVID images, right? But of course, right? So there is some chest X-ray, and this data set has been downloaded from the web. It is now readily available on the web. You can download thousands and tons of images for the patients, and that too in different environments, right? So this is one of the testing data set which I'm talking about, right? So with this, I'm not going to train my model. So this is a normal image, right? So I have these normal images, if you can see. So this is a kind of grayscaled images for us. In the training part, I have some more images as compared to my testing part. So remember, the images should be of the same account, right? So if I'm putting my COVID images as 100, then the normal images should also be 100. Same goes for your testing part. So in the convolutional neural network, right? So if you want to solve the problem of image classification, so I have to come up and work in the steps. So my first step is prepare the data set of images, right? So we don't care what is the size of image, that you need not to worry about, right? So we will use some image manipulation libraries, and with the help of them, right, we would be able to work and take care of that part. So prepare the data set of images, which means that test and train as two directories. We need to create n number of directories which represents n number of classes. So in this use case, COVID and normal are the two directories, both of them available in the test and the train directory, right? And both of them represents as two classes. One is the COVID class, one is the normal class, right? So I have these two classes. So we got two classes. So if I want to come up here and say classes, so I may have this is as COVID and the other one may be as normal. But I don't know, as of now, I don't know that zero index would be COVID or first index would be COVID. So that we'll see once we have trained the model. Can I get an acknowledgement here as a smiley from all of you? We are good till here, guys. So this data set preparation is good to go. Okay, so Tanya says, how is the CNN used for face detection alignment? So Tanya, your face detection alignment, what exactly you are trying to come across here, right? So one is the face detection, which we can definitely do, that this face belongs to this fellow. So if you're talking about the alignments here, right? So this may be some more different algorithms, or maybe we can go with some other part of the model. I think we have to train it in some different way. We need to do some R&D on that part. Okay, so continuing with this part here now. So we are going to come up here and work with this TensorFlow APIs so that I can actually prepare my data set and train this fellow. So let me come here, and first of all, we'll import some very basic helper libraries. I'm gonna say NumPy. Then we are going to come up here and say import CV2, the open CV, so that I can read the images and maybe manipulate them. Then I'll this matplotlib.pyplot, so I can just plot some images here and there. Now from the TensorFlow, what and all I would be requiring, let me write that. So from TensorFlow dot keras dot models, I'm gonna import something known as sequential. Okay, sometimes this indexing won't happen. So guys, before I put this across, right? So you need to install these specific libraries in your system, and the commands are very basic, right? Pip install numpy, pip install cv2, pip install matplotlib, pip install TensorFlow, right? So the other way around is that you can just go to this TensorFlow and they will give you this Google Colab in which you have the environment which is available directly to execute your programs. Okay. So if you want to run it on your system, you need to configure these libraries on the system. So everything is pip install, and the corresponding libraries can be installed. And the IDE which I am using is PyCharm, right? It's pretty much industrial standard. And the other way around to work is you can use some notebooks if you want, and that particularly be a part where you just like to come up and see the outputs accordingly. In a sequential step, you would like to see the outputs and examine the outputs. So proceeding further here, so sequential is one of the models from the TensorFlow Keras, where Keras is a high level API in the TensorFlow, right? And with the sequential, I would be able to create, you can say, one of the artificial neural network model, but I need some more layers. So consider them as APIs as of now, right? So I have this convolutional 2D. So DENS is just one layer of perceptrons, and convolutional 2D is going to be a layer to write a convolutional neural network. And I got this max pooling 2D, so that I can integrate my max pooling layer in the network. So few more libraries which I'm going to work on is from the TensorFlow.keras.preprocessing. And here also we have this image. I'm going to come up and import image data generator. Now, very, very useful library in TensorFlow. If and all you are going to come up and, work typically on your image classification or any image part on your CNN. So this image data generator from the TensorFlow is important, right? So image data generator. Let me very quickly just give a run here. Just want to see if these imports, they actually are good to go for me. Okay, so it says DENS is problem here, right? So it's from the layers, my bad. Just copied and pasted. So from the model, I get this sequential, right? So I'll just write down the APIs. The documentation, of course, is available on tensorflow.org. If you want to just go and see the API documentation, you get to see the documentation here, right? So the link is attached. I'll share the snippets after the session. So sequential API is neural network, right? And what and all layers we wish to have in neural network comes from layers library of TensorFlow, right? So that's how we have, right? To prepare data set for our ANN model. We got this image data generator, right? To prepare image data set. So I think this various different API imports are clear to everyone, right? So make sure if you get stuck anywhere, you can just put your queries over the chat. I would just try to poll the chat and see what and all I can answer, right? Now we need to come up and prepare our data set. That is my first goal, right? So prepare the data set of images. So this will also require some image pre-processing. Okay. So prepare the data set of images with image pre-processing. And let's say we got some train image generator, which is going to be your image data generator. Now, your neural networks, they of course works on fuzzy logic, right? So in the range of ones and zeros. So there is this option that you can rescale your image, right? So I'm just going to say it as 1 by 255. Same way, I will have my test image generator. So I'm just creating this object of image generator, and rescale factor is 1 by 255, right? So we're considering this RGB concept. So from 0 to 255, and that's how you create the object of image data generator, right? So that's the kind of API which I need so that I can free flow generate my data set. Now coming here, let's say your training images, which are going to be your train image generator, right? And then I'll say dot flow from directory. Now this is one function which is available on this image data generator object, right? And what this guy will take as input, this guy will take it as input as your directories path. So this is my COVID-19 data set slash we got this train, right? So this is what is the path. The very first input is the path where your training data set is there. Now if you are preparing the data set, then there may be a target size which you would like to follow. So I can convert my image into 64 by 64. Now I really don't care that what is the size of the image, but I'm just going to convert it to a size of 64 by 64 so that I can process my image as 64 by 64 image. So there can be a batch size. So I can say that it could be a case that, okay, we are going to come up and have 8 images processed at one single time. Then the next thing is one more input called class mode, right? So the class mode here shall go as binary, right? Because I have two classes, right? COVID and the normal. So we get this class mode as binary here. So usage of APIs is typically much more relying on the part how you're going to understand the framework. You need to go with the documentation and you can learn the frameworks very well, right? Now, the second one is this test image generator. Remember, you can even have one single object and you can do it with one single object, but I have just created two objects so that you understand it separately what is what. So with the test image generator, so my path is not the train, it's basically the test. Rest, everything remains the same. So I got my training images and I got my testing images. And the next thing what I can do is I can just plot these images and we can try look into them. If you just want to just see here, you can just come up and see, okay, that this is how the image is. But in your program, if you want to just process the image, that can also work for us. But for that, we just need to come up and maybe I'm just going to write one function itself. Let's say plot images. And could be a case that you would like to take some images as input, right? So very quickly, I'm just gonna use my matplotlib APIs. So I'll say plot.subplot 1x5 with maybe a figure size of, let's take it as 20 by 20. And the axis, maybe your axis.flatten. So I'm gonna iterate for image and the axis in zip of your images and axis, right? So let's iterate, and for every axis, I'm just going to do my image show function, and will show this image, and I would not like to come up and show the axis, so I'll just turn it off. So plotting, or you can even say whatever the way you want to visualize these images, it's totally up to you, right? So I'll just put some more APIs on the matplot and show the plot finally. So assuming that you just want to come up and see some of the sample training images, right? So I'm gonna see some sample training images from the data set which we have created. That's like your training images, right? So I'll get two of the values when I will execute this next on the training images. So this is basically a generator object in Python. So you execute next on the generator object and you will get to see some next images putting up here. Okay, let me just go along and see the chat part. Okay, so Rajinder says, are the augmented images in the image generator stored anywhere? Yes, yes, definitely yes, right? So all these images which we are actually trying to augment and pre-process the data, right? So they will be there in the RAM itself. So we are not kind of processing the data and storing them somewhere on the physical disk. So typically, when we will be creating the model, so Rajinder Kumar, when we'll be actually creating the model and maybe we'll be saving the model on the disk. So there you will be having all these augmented images coming up along with. But typically, these all images which we have created here, right? So they are going to be a part of your RAM area whenever the program is going to run.
Okay, sir. Sir, is it possible to store them?
Storage could be a possibility. But of course, yes, we have to explore some API. Definitely, it's definitely be a possibility, but I think we have to come up with some API here. And of course, you might be taking it for a use case that you want to use these augmented images directly in some other model. Is that the use case?
Yes, sir. But I want to show that how this augmentation takes place when we go for that image generator.
Okay. So I'll just see. Let me just try to wrap up this part, right? So I have one of the pointer here for you. Definitely, I have one of the pointer. I'll just come across with that part.
Yes, sir. Yes. Yeah.
All right. So guys, once we have pre-processed this data, right? I'm just going to come here and say plot these images. So I'll just take these some sample training images and let's try to run the code. Okay, so I think there is some small challenge here. We'll just very quick. So before even that, right? So when I have created this, training and the testing images, we can very well see that there are 130 images belonging to two classes and 18 images belonging to two classes. So typically, what exactly has happened here? Image generator has given this print statement. We are not printing this statement anywhere. So this is a print statement from the image data generator constructor itself. Okay, so that is how it's gonna give it. So just give me a moment. I think some code snippet has gone here and there. So it's gonna be multiple subplots, not one single subplot. So the API call. All right, so let me just put this part here. So I think this part is visible, right? So these images, right? So they have been augmented at the same time, and we have pre-processed these images, and just to visualize it, right? So it's not mandatory that you should be visualizing it. So you already have the images, but of course, if you want, you can have them. And Rajinder ji, so for your use case, right? What we can do, we can even come up, iterate, and just simply save these images with the OpenCV itself. If you want, right? So yes, definitely yes. So the images can be saved with the OpenCV APIs, and but saving the images directly through this training and testing part may not be possible. So moving with this part, so we have these images. The next discussion could be my step number 2, right? So these are some steps which we need to follow. So in the step number 2, we have to come up and create CNN model, right? And this CNN model is going to be nothing but it's an ANN model with convolutional network, right? So this is a combination of your basic neural network along with the convolutional network, right? So let me show you how this can be done. So we are going to work on our second step, that's like creating the model, which is ANN plus convolutional net, right? Typically, you actually create the convolutional net first, and then you kind of put your basic ANN. So considering one reference variable model which points to this sequential object. So in TensorFlow, we are going to work with sequential as the API to create the ANN, right? So we can just write our ANN through the sequential API. And now I am going to come up and add some layers. So we can say model.add. So add is a basic function. And what and all layers you are going to come up and put across, you add them here. So my first layer goes like convolutional 2D layer, right? So now in the convolutional 2D layer, so if you just want to explore the APIs, of course, you have to go with the TensorFlow documentation, right? So API documentation is all available here. I'm just gonna go through this once for all of you, right? So maybe this convolutional 2D. Let's see what we got here in the convolutional 2D. So this is, you can say, the API, which typically we are going to use here, right? So what we got here, we got how many filters you want, then what is the kernel size, then coming ahead, we now anything which is already not available, it will have some default values to work with, right? Then there is some activation function which you need to come up and give, right? So I'm just showing you some of the things which we generally have to work on, right? I'm not gonna put up everything here. Then there is this input shape with which you would be working, right? So this is one small reference link to study what is convolutional 2D as the layer, right? So I've just put up this small link. So the first thing goes like some number of kernels. So I'm choosing 32, and thereafter you can see here, right? So the size goes like 3 cross 3. Then I'm going to choose my activation function, and this can go as rectified linear unit or ReLU as in short. Then what exactly is the input shape? So guys, input shape here should be for the images which you're trying to feed, right? So the images which we're trying to feed, they are 64 cross 64, and the channel associated with them, right? It's basically RGB channel, right? So it's a 3 here for RGB. So that is my very first layer which we have added. And after you have added one of the convolutional layer, then I'm going to come up here and say add one max pooling layer. So max pooling 2D is again going to have 2 cross 2. Let me check. Yes. Now for this part of your pooling layer, you can add several convolutional and pooling layers again, right? And what I'm gonna do next is I'm just gonna add these layers once again. So you can have as many as layers you want. So here we need not to have some input shape, because input will be coming up to the model from very initial layer. That's like the first layer. Rest everything layer is going to work as the hidden layer for us. Okay, so this is kind of one standardized way that how you create a convolutional neural network. And I think we have some, okay, we have one more query here. Can we have control on weights initialization of kernels in Kira's convolutional 2D? Typically, Pankaj, if you can see here, right? So convolutional 2D will not have kind of anything over the weights as in the control for us. But definitely, if you want, you can work with the bias factor. So there is this bias which is available to you, which you can actually work on. But these weights and all those propagation algorithms which would work, it's totally internal to the API. So they are kind of fine-tuned for us, and we need to just write these layers, and internally it's gonna take care of everything. So I'm going to now put across my basic neural network now. So that's like creating the ANN model. So convolutional network, and thereafter we are just going to have something known as artificial neural network to come up, right? So I'm just going to add on one ANN, add ANN to sequential model. So we are just going to say model.add. So I'll include one flatten layer. So anytime if you have to create, so guys, anytime if we are going to work on creating this CNN, right? So this is a standard approach which we generally follow for the TensorFlow APIs, right? So you got this dense layer with some one. So these perceptrons here, the nodes here which we are writing, this can be just increased or decreased as per how the training goes on. So activation is majorly the rectified linear unit, And the last layer for me is this dense layer once again. And I'm going to have one single perceptron with the activation function coming as sigmoid so that I can directly get the results. Okay, so just give me a moment. I think I have some flatten. Just give me a moment. I'll use this flatten as import once so that we can have it here. All right. So we have a very fine query here. So Rajendra Kumar asking that if we add some more layers to the network, will that result in overfitting? Typically, yes, it can be a use case where we can actually fall into this trap of overfitting. But TensorFlow as a framework, whenever you execute its training function fit, it internally optimizes everything for us. Let me show you how, right? So there may be a case I can take 256 perceptrons here, right? So I may take up some wrong parameter here and there, but there is some classical approach that how, of course, working with your own models can be a challenge, but when I'm working in the TensorFlow layer, this is one fine step where I'm going to optimize my model and I'm going to eliminate all these fears. So guys, the step number 3 is basically the answer to the query from Mr. Rajendra Kumar, right? So what is this step number 3? That's like compile the model. So compilation of the model is typically a part where, let me come up and say compile the model. And I can even write this print statements, right? So just give me one more moment where I'm just putting up this small statements. Compiling. Then here is adding neural net. Then here we got adding convolutional net layers. And this is basically model creation, right? So I'm just putting up these print statements so that once we execute the code, we just have a log on it. All right, so last part is my model dot, not the last part, but the next step, right? So model dot compile. So in this compile function call, we got something known as optimizer. So there is this AIMLDS algorithm, right, which is going to work on my optimization. Then I need to compute my losses on the model, right? Since I'm working on image classification, which is a binary classification problem here. So I can work with my binary cross entropy. And then in the metrics, so what are you expecting is kind of maybe accuracy on your model. So compile function from the TensorFlow APIs on the model will actually keep all your fears away. So good to go here, Mr. Rajendra Kumar, with your query, right, as well. So proceeding in the next step is how am I going to come up and train the model, right? So let me come here with the last step, which is training the model. Okay. So my fourth step is training the model. Now, generally, whenever you will be working on TensorFlow framework, right? So the function is fit. It is very much same function from the sklearn, which we actually come up here and work on. But when it comes to training of the model with respect to this data set from the image data generator, we have a different function to use here. So I will not be using this regular fit function from the TensorFlow. Rather, there's a function called fit underscore generator, right? So you pass your training images and you decide the number of epochs. Let's train it for 5 epochs. So you can decrease the epochs, which is kind of a knob. And of course, we can try achieving the proper results. So last one is my validation data, which you put it as testing images. So this is what fit generator gives us for, right? So you are going to train the model with the training images with the 5 epochs, right? And validation data comes with testing of the images here. Now this function or fit generator function, they returns us a history. Now what history is basically a dictionary, right? So history as a dictionary is going to come up and provide us key value pairs. So my accuracy will be available in the history dictionary with the key called accuracy, right? And thereafter I even have something known as value accuracy, which is available as my value to the accuracy. So these are the keys which would be available from your history, as you can say the data part. So same way, we got accuracy and the validation accuracy here, right? So we have the loss. So let me just come here and take it. So you'll have the loss and then the loss for the validation. So this is after my step number 4. I have trained my model. So what am I trying to do is I'm trying to come up and bring this part here, where we'll just visualize the model performance, right? So that is something which I'm going to bring on here. Let's come here and say the 5th part, visualize the model performance. So visualizing the model performance, I'm doing it over the 5 epochs. So there are 5 epochs. On them we are trying to come up and do this visualization. So my epochs, that's nothing but that's kind of, you can say, a range function for 5. There are 5 epochs. So I'll get a list basically, right? And let's draw one plot. So I'm gonna have a figure size of maybe some 8 cross 8. Then I'm gonna draw one subplot here. Let's try to plot epochs as X and then the accuracy as Y, and I'm going to give one label here as training accuracy. Then we'll plot validation accuracy. And on the plot, let's put legend so that we can just see the labels. And I'm just gonna put some location, maybe the lower right hand side. And let's give this plot one title. And putting this title as accuracy maybe, right? So this is my subplot 1, and then I got 1, 2, and 2, right? So this is the another subplot, and here we'll put up our training loss. So over the 5 epochs, we are trying to visualize what is going to be the accuracy and what is going to be the loss. So this guy, I'm going to put it as maybe upper left. and we got this guy as loss. So finally, let's say plot dot show. Okay, so this is what we have got within some steps here, right? And we're just gonna run this code and at least see. Okay, Tanya says, what are epochs? So Tanya, when you are going to train the model, so how many number of times you will be training the model, right? So that is epochs. If you see epoch 1 by 5. So this is my very first iteration in which I'm training the model. I have higher losses and less accuracy, right? So as the model gets on to the next epoch, my losses, they are decreasing and my accuracy is kind of going higher, right? So that is the kind of epoch which we are trying to understand. Yes, exactly, with the same data again and again, so that my model actually works on some weights here, right? So this is the training accuracy and this is the kind of loss. So loss has been significantly reduced. And of course, guys, whenever I will run this program again, right? So you cannot consider the part that every time you will get to see the same graphs coming up. Okay, so what is the reason here? So Kira's TensorFlow internally, when it's gonna come up and create the ANN model, so the weights are assumed randomly. So I'm not working on any learning rate. I'm not working on any updation of weight. So that is all taken care by the APIs automatically on behalf of us, right? So that is how everything happens internally to the API part. So eventually you will get this kind of a result on your data set, right? That's how we see this kind of a training loss versus the accuracy part. So we are good to go till here, guys. So an acknowledgement awaited as a smiley from all of you. If we are good to go till here, I have few questions to answer, of course. So with the same concept here, or maybe whatever the discussion we are having on the CNN part, I hope this part is clear to everyone, right? Okay. Now I have one more query from Shruti. Are we applying linear regression here? So nothing like linear regression here, Shruti. So that's altogether a separate use case. So Priyanka saying, could you please suggest some small projects on augmented reality? Okay. So Pankaj saying with the latest version, model.fit is good to go. All right. Great. Thanks for the input here, Pankaj. Thank you so very much. So batch normalization is not mandatory to add. Typically, this is when you're trying to, let's say, train the model with a lot of larger data set, right? So you may try to come up and take data set in batches. Let's say you have some maybe hundreds and thousands of images to train on, right? So you can consider those batches to come up and make your model to work on. Okay, now let's see my last part of discussion where I created these two classes in the very first go, right? If you can see, we have two classes. So one is this COVID, one is this normal, right? So I'm going to have this image, which is my CV2 dot. Let's use this image read function, right? And let me take the path here. So just give me a moment. So I got this COVID-19 dataset / test. Then we'll take one of the images, maybe from the COVID, right? So I'm just going to consider this COVID here. and let us take one of the images. So let's take this first image here, right? So this itself is the image. Let me just do a copy of the name and put it here. So this is the image which I'm reading through this OpenCV as library, right? I'm just gonna read this image, and let's say image is image dot resize the image, and the new shape which I'm going to give is my 64 by 64. And finally, we have this image which is numpy dot reshape. So I'm gonna have this image with 164 and 64 and 3, right? So there is some RGB channel which we're just going to come up and put here. So let's say my predicted class your model dot maybe predict underscore classes, and you pass this image. So what we did here, we are kind of reading the image, right? So this image which I'm reading here is basically COVID-19 chest X-ray image. So it's basically COVID patient's image, and we are kind of feeding this image to a function called predict underscore classes, and that too on the model which you have trained, right? So we'll come here and say print me the predicted class. Let's see what output it would give us. And in between here, I'm just going to comment this plot images. So I'm not going to plot any image. Okay, so this training will entirely go again. And we definitely have something known as H5PY, and we have the functions to, directly save these models. Once you have created these models, you need not to come up and retrain them every time. So that is one more part of the discussion maybe. Okay, so I think we have one small problem here. Let me just kind of go and look into it. So I've read this image and we are trying to so if you can see guys, right? So the first thing here is that we have a lesser loss and a better accuracy. So the last part of our discussion here is that I'm just going to kind of, okay, so my bad. So it's the resize function has to be executed on my CV2. So that was one API call issue. So on the CV2, we are just going to do a resize on the image to 64 cross 64, right? And then we are going to add one RGB channel to the image, giving it to the model to come up and give us some prediction maybe. So the last epoch. All right, so this is coming as 0, if you can see, right? So this predicted class comes out to be 0 for me, right? And now let's comment this image and pick up some image from the normal data set, right? So from this normal data set, maybe we take this last one, right? So let's take this last one. So this is test COVID, not the COVID one. Here we have it from the normal, right? So now what I have done is I have taken up one normal image. So this is the normal image which we have picked up, right? So COVID-19 data set, and this is all testing data, right? Which we haven't trained the model on. So we trained the model with this train COVID and normal images. All right. So these normal images, right? So we have trained, and validation we have come up with the testing part. Now let us check it, what output it gives for our normal image, how the model would work for the normal image. Guys, here you can see the output is now coming as 1, right? So typically 0 was the COVID infected image and 1 is the normal image. So that's how you can see two different classes, 0 and 1, coming as in the output. So 0 is your COVID and 1 is the normal, right? So I can even come here and say, print me classes of this, maybe predicted classes of 0, right? So we get this kind of list here, right? Whose 0 index is the one which you are trying to come across and use maybe. So I think this is going to be list of lists. So I can just say zeros 0. So that first index can come up and give me the normal as output, right? So if you want. Now the same program which we have created can be fused with web applications like Django or Flask, so that you can give a user interface and people can actually try, pick up the images, and then we can give them an option to upload the images and to test the images. So I can even show you one small demonstration on that. I definitely have one of the programs on that. Just give me a moment. Okay. Right. So you see now the text coming as normal. Okay. So I have this one of the programs. I'm just gonna run it. So it's a web application done on the Flask, and of course there's a framework with which you can write web applications. Let me just open this. So here we are, right? So you can kind of write this small web application. Then you can actually choose a file. You can upload it, and thereafter it's gonna give you some results on the prediction maybe, right? So this is one of the final end products which you can actually write. And anytime if you want to come up and save this model, so we do have the APIs with the help of which you can save the model and you can reuse them, so that you need not to train them again and again. So this is what I got for all of you for the day. So in case you have any queries, we are open up for that now. So one of the queries was, just give me a moment, I'll just log into my chat here. Okay. Okay, so one of the queries was if we can save these augmented images. So we can try iterating. Let me check from where we got this. Yeah, so Rajendra Kumar, we can actually iterate in these training images or in the testing images, and we definitely can save them with the CV2 image write, maybe, right? So CV2 image read and CV2 image write. So you can read the image and you can write it. It can be saved. Then I have another query from Pankaj, but can we use validation images in testing and claim better accuracy? Yes, we can do that. Then there is an option, there's a query for a multivariate regression model. Then there is one more query. Can you please explain how to merge ML code with the Flask? Well, okay, Tanya, so that would definitely require some more time for where we can actually have session planned. Maybe I can just share one of the repository links or the code snippets itself, that how it's gonna work, right? So that way it can, I think, work. So for Sasanto Sekhar, so multivariate regression model for image classification may not be a particular fit for our particular use case here. It can work in a different use case where I think that in case we have some more different features to come up and do some prediction on how we can actually bring on some test results, may not be associated with the images. Okay, what type of algorithms can be used to get better clarity on what? So Balakrishnan, on what we're expecting here? I mean, better clarity on what? So of course we have algorithms, but a better clarity on what? You want a better clarity on data, on the outputs? Okay. So convolutional neural network is one of the models, right? But typically in past few of my projects, which I have actually been working on. So RCNN is one model which you guys can try exploring. Then the fast RCNN and the faster RCNN, right? So these are the models on which you can actually explore more. Then we got this mask RCNN. So this I have been using in a couple of my projects, right? So this is from the Matterport. So I would personally come up and say that you guys should definitely work on this model, right? Mask RCNN. So given a chance, right, we can have some other webinar, or maybe we can talk about mask RCNN. So I use this part where we captured the parking site image and we computed how many two-wheelers or how many four-wheelers are available on the parking site, right? So we can actually take a live CCTV footage and we can analyze what and all is happening on the street. So this is just one input to the query raised by Balakrishnan. So I can share this link over the chat to all of you as well.
Hello, sir.
Hello. Yes.
Sir, Pankaj Kasar here.
Yes, Pankaj.
Sir, my query may be beyond your scope of today's discussion. I want one help regarding, there is one utility in Keras regarding distributed training.
Right.
So suppose there are multiple GPUs with multiple graphics card. So if I want to use that particular multiple GPUs with suppose multiple graphics cards, so there is a utility, multi-worker distributed strategy.
Correct.
So I want, I cannot access those GPUs, sir. Means multiple hosts with multiple cards. Typically, so currently I am not able to run my code on that particular.
Typically you are trying to even work on these different nodes here, right? And you have to involve networking here at the same time.
Yeah. I can run my code, means I can access GPU when there is a single host and multiple cards. So there is a multi-mirror strategy
I got
I can definitely use, and I am using that,
typically,
but I
yeah.
cannot go with that multi-workers. That means I am not getting how to go to that.
Typically what we can do is here we can just have one small, I think we can have one sharing of what you have been doing on your work. I may be able to suggest you what you have done exactly on the basis of that. Maybe you share your some of the R&Ds, then I would be able to look into it, what is going right and what is going wrong.
Okay.
So just need to kind of, you can see I need to do some debugging in what you are trying to do, but your approach is correct, right? So there is just that how you are actually deploying it to the network, maybe some challenges there.
Yeah. Okay. Okay. So just like when there is a single host and multiple cards, so there is a like, sir, just tf.distribute.mirror strategy, and then you have to just compile your model and create your model and compile your model.
Yes.
And then
yes,
separately you have to fit. But in multi-worker strategy, I'm not getting how to proceed with that. I tried with the same, but still the GPU access is not
I
there.
would be happy to help on that. I just need to do
Yeah,
some
sir, please,
small
please.
R&D. I need to do some small R&D on the same, and please definitely try to get connected with me.
Sir, please your email ID, please, so that I can.
After the session. Yeah, I'll share my email ID. So here is my email ID, er.ishant@gmail.com. I'm just putting it over the chat, so we can just kind of connect and I can see how I can help you more on the same. All right.
Thank you, sir. Thank you very much.
Yeah, welcome. My pleasure. My pleasure. So this code snippet, just for the review part, I'm sharing it over the chat as well. I think it should go or not. Let me check. No, it's not allowing me. Okay, let me share this file maybe. It's not coming up as an option. Okay, what I can do is I can share this file, right? So whatever the code we have done, I think there it may be circulated, Mr. Singla or Kiran ma'am.
Yes, sir. You please can forward to me and I will forward to the candidates.
Right. So this is all from my side for the day. Thank you so very much for being a wonderful audience. And I just hope that I would be able to answer a few of your more queries. You can always send it to me over the chat and I would try to respond to you guys. Thank you, guys.
Thank you, sir. Thank you. Thank you.
Thanks, Nishant sir, for sharing such a nice and informative hands-on session on deep learning based classification model for a really recent problem, that is COVID-19. So again, I am thankful to Mr. Ishant on the behalf of our HOD and the entire management of Guru Nanak Dev Engineering College, Ludhiana. Thank you, Ishant sir. Thanks a lot.
Thank you, Ji. Bye-bye.
And there's one more announcement for the participants. The tomorrow's session will start 15 minutes earlier. We'll start at 9:15. Okay? We'll start the tomorrow's session at 9:15. Please join 15 minutes earlier for the session. Thanks again. Thanks all the participants to join this day 5 for the STTP. Again, really thankful to all of you. So we'll meet you tomorrow at 9:15. Thank you.
So today you are going to launch a quiz. Is there today any quiz, sir?
Today there is no quiz. quiz will be tomorrow. Because last day is tomorrow.
Tomorrow.
Okay.
Yeah.
So any other query? My feedback link has been shared. You can use that link. So again, I'm requesting you, tomorrow's session will start 15 minutes earlier.